Welcome to episode 431 of AI Brief. If you are prepping for a major strategy meeting today, or if you simply possess an insatiable curiosity about the technological forces that are completely rewiring our world, you are in exactly the right place. Our mission in today's deep dive is to extract the absolute most critical advancements happening right now in the technology sector and deliver the insights you need to stay ahead of the curve.
We have a truly massive lineup for you today.
We absolutely do. First, we are looking at extraordinary leaps in mass chip production, courtesy of a massive breakthrough at ASML. Then, we are going to unpack Nvidia's brand new processing chip, which features a highly unexpected partnership.
Following that, we will survey the latest advancements in artificial intelligence and robotics, including incredibly agile robot dogs and new humanoid helpers entering the consumer market.
And finally, we will round out the deep dive with the trending AI tools designed to immediately supercharge your daily productivity. Let us jump straight into the developments in hardware manufacturing.
The advancements we are seeing today are not just incremental updates. These are foundational shifts.
ASML Holding has officially crossed a monumental threshold. Their next-generation chip-making machines, these are known as high-NA EUV tools, are now officially ready for high-volume AI chip production.
To understand the sheer scale of this achievement, you really have to picture the manufacturing floor. These machines have already successfully processed 500,000 silicon wafers.
And these are not tiny components we are talking about. Each of these wafers is roughly the size of a standard dinner plate.
Processing 500,000 of them is just a massive flex.
Yeah.
It proves this technology is not just theoretical anymore. It is fully operational.
It is the definitive proof of concept. The core functionality of these high-NA EUV tools lies in their ability to draw ultra-precise circuit patterns onto the silicon.
In the world of semiconductor manufacturing, precision is absolutely everything. Think of traditional chip manufacturing, like trying to draw a highly detailed map with a thick marker. It works, but you are limited by the physical size of the marker tip.
ASML's new extreme ultraviolet lithography machines essentially give manufacturers an ultra-fine tip pen,
which allows them to draw much denser, incredibly complex roads on the silicon in a single stroke.
And what I found so brilliant about this is the cascading effect it has on the rest of the manufacturing line. By achieving this new level of density in a single pass, ASML allows chip manufacturers to eliminate several highly complex and incredibly costly steps from the traditional chip manufacturing process.
Every single step you remove from semiconductor fabrication reduces the chance of defects. It significantly minimizes machine downtime. It is a massive win for overall efficiency.
The timeline for this rollout is also remarkably aggressive.
Full integration into global manufacturing facilities is projected to be 2 to 3 years away, but ASML expects these machines to reach a 90% uptime reliability metric by the very end of this year.
It directly enables the titans of the industry. Companies like TSMC and Intel rely entirely on ASML's lithography machines to push the boundaries of physics.
By giving Taiwan Semiconductor Manufacturing and Intel the ability to mass-produce these vastly more powerful and efficient chips, ASML is effectively guaranteeing the future roadmap of the entire AI industry.
Because software companies rely entirely on hardware catching up to their ambitions. The massive computing power required to improve large language models demands this exact next generation of silicon.
Furthermore, as these chips become more efficient to produce, we are going to see a rapid acceleration in edge AI.
That means artificial intelligence that runs locally on your devices without needing a server connection. We are talking major leaps in industrial automation and complex data processing.
The foundation is actively being laid down for the software of tomorrow.
Moving from the manufacturing equipment to the chip designers themselves, Nvidia is making a strategic maneuver that is going to fundamentally alter the speed of artificial intelligence.
Nvidia is currently developing a highly specialized new processor that is explicitly designed for inference computing.
This new platform is scheduled to be officially unveiled next month at Nvidia's GTC Developable Conference in San Jose.
To make sure we are all on the same page here, inference computing is the specific phase where an artificial intelligence model actually does its job.
While training a model is like reading the entire library over the course of several months to learn a subject.
Inference is the real-time processing that occurs when you ask a chatbot a specific question and it generates a response on the spot.
Currently, the industry faces a massive bottleneck regarding inference speed and efficiency. The demand for immediate, complex AI responses is completely overwhelming the existing hardware infrastructure. Everyone wants their answers instantly.
What makes this upcoming announcement from Nvidia particularly fascinating is the architecture of the platform itself. Nvidia is actively incorporating a chip designed by a startup company named Grok.
Seeing an established, undisputed hardware titan like Nvidia integrate specialized technology from a much smaller startup highlights a major shift in how these companies approach problem solving in this current landscape.
I found that partnership incredibly unexpected. You rarely see the biggest player in the space reach outside their own walls for core architecture.
But it demonstrates an acute awareness of market demands. Companies like OpenAI, which are NVIDIA's largest customers, are constantly seeking faster and vastly more efficient systems to run their models.
They cannot afford to wait for a 5-year internal development cycle. Grok has built a formidable reputation for designing hardware architecture that excels specifically at the rapid execution of AI tasks.
By collaborating with a specialized startup, NVIDIA bypasses years of internal development.
They can immediately offer a highly tailored inference solution to their enterprise clients. This partnership emphasizes that the demand for efficient AI processing is so immense that even the undisputed market leader is willing to integrate outside innovation to maintain its competitive edge.
They are prioritizing speed to market over absolute internal control to support the explosive growth of complex machine learning applications.
So if companies like ASML and Nvidia are building the ultra-fast, highly capable brains of the future, someone has to build the physical bodies to house that intelligence.
Let us transition into the latest developments in robotics. We need to carefully and methodically evaluate how these software advancements are breathing life into mechanical frames.
Our examination begins with the Chinese robotics firm Unitree. They have just introduced a highly capable quadruped robot designated as the AS2.
When we analyze the physical specifications of this machine, the engineering metrics are quite remarkable. The AS2 is designed to carry reasonably heavy equipment payloads while simultaneously navigating highly complex, unpredictable terrain.
It possesses the mechanical articulation required to climb steep slopes and navigate standard human staircases with complete ease.
Honestly, the specifications on Unitree's new AS2 robot dog are almost intimidating. This piece of hardware is sprinting upstairs at 11 miles an hour in the pouring rain while carrying heavy gear.
It is entirely weatherproofed, built specifically to survive sustained exposure to heavy rain, dense dust environments, and extreme temperature fluctuations.
This is not a fragile laboratory prototype. It is a ruggedized piece of industrial equipment.
The application of such a durable quadruped extends far beyond simple novelty. We are observing a calculated shift toward deploying these machines for rigorous, real-world utility.
This means we can finally deploy these mechanical units into environments where traditional wheeled robots inevitably fail or become immobilized.
In locations such as disaster zones covered in unpredictable debris or multi-level industrial facilities lacking customized architectural ramps, the AS2 provides a highly viable, robust solution.
The deployment scenarios include complex industrial inspections, navigating uneven terrain for outdoor logistics and deliveries, and providing critical situational awareness during emergency response scenarios.
Parallel to this advancement in quadrupedal mechanics, we are witnessing a significant strategic pivot within the consumer electronics sector. The Chinese smartphone manufacturer Honor is officially entering the high-stakes race to develop humanoid robots.
They are preparing to unveil their very first humanoid helper, designed specifically for home and retail environments, at the Mobile World Congress in Barcelona next week.
This development requires us to analyze the broader pattern emerging among telecommunications hardware companies. Honor is joining other prominent smartphone manufacturers, such as Xiaomi, in making substantial capital investments into agentic artificial intelligence platforms.
An agentic platform is one where the artificial intelligence is not merely responsive to direct user commands, but is capable of autonomous action and complex, multi-step task execution within a physical three-dimensional space.
The synergy between their existing smartphone product lines and this new robotic hardware is the crucial element to examine here. Honor has explicitly stated that this new humanoid robot will operate in tandem with their upcoming mobile device, which they are currently categorizing as a robot phone.
This strategy indicates an attempt to build a comprehensive, interconnected ecosystem. Rather than treating the humanoid robot as an isolated household appliance, Honor is positioning their mobile devices as the central command architecture for physical automation.
This effectively extends the concept of mobile computing far beyond the glass screen you carry in your pocket. It transforms the smartphone into the neural hub of a mobilized physical household assistant.
The mobile device processes the complex environmental data, and the humanoid robot executes the necessary physical tasks.
The final piece of our robotics analysis involves a major corporate restructuring at Alphabet. After operating for 5 years as an independent entity under their other bet category, Alphabet has officially absorbed its robotics software startup, Intrinsic, back into the core infrastructure of Google.
The strategic implications of this consolidation are immense. Intrinsic specializes in developing no-code software tools specifically designed to make industrial robots accessible and highly intuitive to program.
Instead of requiring a team of highly specialized engineers writing complex code just to direct a mechanical arm to pick up a box, Intrinsic allows facility floor managers to orchestrate robotic movements through accessible visual interfaces.
By pulling this company back into the primary corporate structure, Google is signaling a direct, aggressive entry into the industrial automation sector.
Google is not just making robotic arms easier to program. They are plugging those physical robotic units directly into Google DeepMind's massive artificial intelligence models.
And backing the entire operation with Google's immense cloud computing infrastructure, they are clearly gearing up to engage in direct competition with established logistics giants like Amazon, as well as automotive innovators like Tesla, who are currently heavily investing in automating the physical supply chain.
The consolidation of these three pillars, accessible robotics programming, advanced artificial intelligence modeling, and massive cloud computing power, creates a truly formidable platform.
It suggests that the future of industrial manufacturing will be dictated not just by who manufactures the most capable mechanical arm, but by who provides the most intelligent, scalable software to control thousands of those arms simultaneously across global logistics networks.
Google clearly intends to be the primary operating system for the automated supply chain.
Let us shift the energy back up and bring these massive technological concepts down to the highly practical level. It is time to explore today's trending artificial intelligence tools that you can deploy right now to immediately supercharge your workflow.
Whether you're managing marketing campaigns, developing mobile software, or creating digital content, these platforms are engineered to save you countless hours of manual labor.
The first tool on our radar is Pixel. For anyone working in digital marketing, managing ad spend across multiple networks is notoriously complex. Pixel serves as a unified command center.
It allows you to scale performance advertisements seamlessly.
If you work in digital marketing, you know the absolute nightmare of Friday afternoon campaign reporting. You have a dashboard open for Meta, a tab for Google, another for TikTok, and you are trying to manually balance budgets across all of them.
Pixel completely eliminates the persistent headache of juggling 7 different ad platform dashboards simultaneously. Get one centralized hub to scale your performance ads efficiently.
Next up, we have a major update for mobile developers, the Google AI Edge Gallery. This tool brings on-device function calling directly to the Apple iPhone.
By processing the artificial intelligence functions locally on the physical device, rather than constantly routing requests through a remote cloud server, you drastically reduce latency.
It improves the offline capabilities of the application tremendously. It is a massive step forward for responsive mobile application development. The user experiences zero lag because the compute is happening right there in their hand.
For the creative professionals tuning in, Producer AI by Google Labs is an incredibly fascinating development. This platform functions as a highly capable, tireless AI co-producer.
You can input your raw musical ideas, vocal melodies, or basic rhythmic concepts, and the system works alongside you to structure, mix, and generate complete musical tracks.
It effectively democratizes music production by completely removing the steep technical barriers associated with complex audio engineering software.
You no longer need to spend years learning how to balance equalizers and compressors. You just bring the creative vision, and the AI handles the technical execution.
In the e-commerce space, visual presentation directly correlates to revenue. You need incredible imagery to convert browsers into buyers. CellShots is a new tool that generates high-converting, professional-grade product photos in a matter of seconds.
You simply provide a basic, unedited image of your product taken from your phone.
The AI then places that item into highly realistic, beautifully lit lifestyle environments.
It completely eliminates the need for expensive studio photography sessions, location scouting, and professional lighting rigs. You get a perfect product shot ready for your storefront instantly.
If you are frequently using advanced language models, Prompt URLs is an incredibly practical utility that is going to save your team so much time.
It allows you to take any complex multi-step prompt that you have perfectly engineered and instantly turn it into a single, highly shareable URL.
You can then distribute this link directly to your team, allowing them to execute your exact workflow, specifically within platforms like ChatGPT and Claude.
It completely removes the friction of having to copy and paste dense paragraphs of instructions over messaging applications. You just send the link, and the optimized prompt is ready to run.
Finally, we are looking at the Claw News. This platform is a brilliant demonstration of autonomous workflows in action.
It utilizes OpenClaw artificial intelligence agents to actively scour the web, synthesize complex information, and publish daily news updates completely autonomously.
It is a clear, highly effective example of how agentic AI can take over routine content curation and distribution without any human intervention.
Each of these tools represents a microcosm of the larger trends we discussed earlier today. They take highly complex multi-step processes, whether that is media buying, music production, or photography, and condense them into highly efficient, seamlessly automated actions.
As we wrap up this deep dive, I want to leave you with a final thought to consider as you look toward the horizon of consumer technology.
We are currently witnessing two massive parallel tracks of innovation moving at unprecedented speeds. On one side, semiconductor giants like ASML and Nvidia are radically accelerating the speed and efficiency of the brains of artificial intelligence.
On the exact same timeline, hardware companies like Honor and Unitree are radically advancing the physical bodies that can house this incredible intelligence.
When these incredibly fast neural networks merge seamlessly with these highly capable, weatherproof, and extremely agile physical frames, the traditional definition of household tech is going to completely transform.
We are not just looking at smarter screens or faster search engines. We are looking at an entirely new category of autonomous physical assistants that will fully integrate into our daily lives and workplaces within the next 3 years.
The convergence of unprecedented computational power with highly robust mechanical engineering will completely redefine the boundaries of what machines can accomplish in our physical spaces. The digital world is stepping out of the screen and into the physical environment.
If you found the insights in today's deep dive valuable, please make sure to follow the podcast on your platform of choice.
And share this episode with a colleague or friend who needs to stay ahead of the technology curve.
See you in the next episode.